All right, I think I have my audio issues taken care of, or at least I hope they are. This is pages 22 and 23. It is for homework on your schedule, and today we got through as much as I think we could get through, but you really need to pay attention to this tonight, and so that's why I'm going over all the homework with you on pages 22 and 23. All right, and so because I know that on 23, okay, there's nothing on there. All right, so you really need to make sure that you watch this, and you really need to make sure that you have this done. Okay, so of course, whenever we start with any proof, okay, whatever they give us, okay, is given. All right, now when I take a look at step 2, okay, step 2. If E is the midpoint of AC, anytime that you have midpoint, next step is always going to be that you're going to have AE is congruent to EC. Because again, this is what, if they're telling us this is a midpoint, okay, then I know that this has to be congruent to that. Or actually, we can just make it equal. All right? Because we're going to deal with what I just wrote, we're going to have that in step 5. So all of this is just creating an argument. So now if I go to 2, then I know that this is definition of a midpoint. Okay? So now go to step 3. Okay, I have now, again, based on our drawing here, if E is the midpoint of AC, they also tell us that DE is equal to EC. Now, if they give that to us, then we naturally write right here, given. Okay, so the first one, again, anytime that you see midpoint, you know that the next line is going to be AE is equal to EC. Okay? So now, number 4. Okay? Since this is equal to this, all right, and if you want to, let's just, so that it's easier to follow. If this is equal to this, and then this is equal to this, okay, so AE is equal to EC. EC is equal to DE. I can naturally say that AE here is equal to DE, which is what you see. All right? So if this is this and this is this, then that equals that. It's transitive. Okay? And so now on step 5. Okay? Step 5. So now, if AE is equal to this, then I know that this is true. Now we could have held this all the way down and could have stopped basically here at step 4, but again, we're just trying to break this out into as many pieces as possible. So now on step 5, anytime I go from here to here, that's congruence. Okay? And so now, number 6. Okay? So if AE is equal to DE, they ask us to prove DE is congruent to AE. Okay, so if that is true, okay, if DE is congruent to AE, okay, whenever I'm able to go from here and I switch it, that's symmetric. All right. Okay, and you should be able to see that on there. Okay, so that's number 1. Okay, so now on to problem 2. Okay, again, we're on pages 22 and 23. Okay, there's no point in erasing this top line right here on the reasons, because I always know that the first one is given. Okay, so now if we're taking a look at, actually it's number 8, my apologies, number 8 on page 20. What we just did was number 7 on page 20. 2. I'm going to get this right, I promise. All right, yeah. Okay, I forgot that this is a continuation of the practice, what I assigned. And so we are on page 22, and we're looking at number 8. Page 22 and looking at number 8. So I have RS is equal to 1/2 RT. That is given. Now at the very bottom, since this is 6, okay, I've got to prove that S is the midpoint of RT. Okay, S is the midpoint of RT. So now I drop down to point 2, where basically what I'm doing is that I'm bringing this over to here. And the reason why is because I'm trying to get RT by itself. So just like we would any other time, multiply by 2. So if I take 2 times RS, that's going to equal RT. That's just simple multiplication, just like we did with algebraic, okay, multiplication, right? Then on number 3, okay, I have, if RS is equal to 1/2 RT, 2RS is equal to RT, okay, then I know that if I look back at my example, okay, and look right here, all right, where the line is, I know that RS plus ST is equal to RT, okay? So I know that this is equal to this, all right? Do you see the corresponding parts there, all right? So, but when I look at this part, I know that it's segment addition. Okay, but also when I see these two, I know that, okay, we're going to eventually somehow bring this back in. And we do in step 4. To where now, if 2RS is equal to RT, then I can plug this into here. So now I can say that 2RS, or I should say, if we keep it the same, RS plus ST is equal to 2RS. Okay? And that's just substitution. Okay, and I'm abbreviating here so that this is not so long. Okay, so then in number 5, all right, well, I've been able to say that RS plus ST equals RT, RS plus ST equals 2RS, okay? So now, can I say, okay, that RS is equal to ST? Okay, can I say that RS is equal to ST? And the reason why I can say that is that if I take ST over to both sides, okay, if I take away ST from here, I'm back to where I was. RS equals 2RS, okay? RS equals RT. So if I subtract them, I know that they're equal. And if they're equal, then I know I can write it. So RS is equal to ST. Okay? And again, that's subtraction. Because what I'm doing is that I'm removing the STs from both, getting back to RS is equal to RT. Okay? Or I'm sorry, when I subtract both off of here, do you see what happens with RS? RS is equal to RT, RS is equal to 2RS. So if that's taking place and I come up with the same amount, then I know RS is equal to ST. Okay, and by subtraction, and then I'm able to prove that S is the midpoint. Okay, and that is from just your midpoint definition. Okay, so I think I'm living up to my statement, or this is revealing to you when I told you that this is a completely different type of math than anything that you've seen before. Okay, so now, number 9 on page 22. Okay, we're going to start where M is the midpoint of Ln. Okay, we always know that's given. Okay, then in step 3, I'm going to go ahead and give this to you. N is the midpoint of MO. All right, and that's given as well. Okay, so you know that whatever you're given, okay, you know you're going to use throughout. And you know that it's a given, okay, this is a given, that is a given, LM is congruent to NO, okay, so as we work our way down, all right, we'll be able to show that based off of this figure right here, okay, this one right here, look at it, it will help you with some of what you need to know. Now, if they're telling us that, okay, that the definition of a midpoint, okay, then I know that LM is equal to MN. Okay, M is the midpoint, LM is equal to MN. And if N is the midpoint of MO, then I know that MN is equal to NO. Okay? Well, if MN is equal to NO, and again, that's midpoint. Okay, so you see given, midpoint, okay? So now, LM is equal to MN, okay? So now, if that is true, then I can write LM is equal to NO. Well, if LM is equal to MN, MN is equal to NO, LM is equal to NO, okay? That's when I have transitive properties. Okay? So, when I go from here to here, to where it goes from equals to congruence or congruence to equals, I know I have to use definition of congruence. Okay? All right, so that's 7, 8, and 9 on page 22. So now let's flip over to page 23. Okay, so page 23. Okay, again, it's 6 column proof or 6 row proof on 10, 7 on 11, and 7 on 12. All right, so we always know Y is the midpoint. Okay, and some of you are saying, well, that's all I'm getting right now. Well, think about, you're at least gaining in knowledge, okay, to where you know when you see this, oh, I know that my next step's going to be this, okay? So now I have to prove that xy is equal to 1/2 xz. Okay, well, let's just start working our way down. Whenever we see y is midpoint of xz, okay, I know 100 times out of 100, okay? The next line, sorry. There we go. Okay, so the next line is xy is equal to yz, and that's midpoint definition. Okay? So now, if I add xy twice, okay, it's going to equal the whole line, or xy plus yz. And the reason being is because when it's the midpoint, they're cut in half. Okay, so I can take 2xy is equal to xy plus yz. Okay, and that there's a couple of reasons you could add, but just for simplicity, we're just going to use addition. Okay, and again, the reason why I did that is because I'm originally going to look at 1/2. So that means that at some point down here at 1/2, at some point I would have had to multiply something by 2. So now I take that part. Well, if I always look at my line, okay, whenever you have a line that you're doing, which is what we're doing here, and I have xy plus yz is equal to xz, okay, well, that is segment addition, to where that is what, okay, I'm getting towards, or not I'm getting towards, but I know it's going to be in there. Anytime you see midpoint, you know that xy is going to have to equal yz. Whenever you do have a line, pretty much always, you're going to have to show or remind everyone why that particular line equals that. Okay? So, I now have xy and yz is equal to xz. Just like I had 2xy is equal here. Okay? Well, now, if I take 2xy, all right, if I take 2xy, I know it's going to equal xz. Because if y is the midpoint, then I know xy and yz are equal. If I take 2 times xy, all right, then I know it's going to equal that whole line. If I take xy plus yz is equal to xz, I know that this is my segment addition. If I add these two parts of the line, they're going to equal the total. So now I can take 2 times this amount, the xy, and I can make it equal xz. Okay? So do you see how I'm able to do that? Because 2xy is equal to this. If xy is equal to this, xy plus yz, what we wrote here, is equal to xz, then I can take this and equal to this. All right? We're just cutting this part out now, and that's transitive. Okay? So now my last step, okay, if I get xy by itself and divide xz by 1/2, I know that that is just simple division. Okay. Hopefully now, and I really hope, okay, that you're able to see what we're putting and why we're putting some parts here and there. Okay, so that you're starting to see a process, so to speak. All right. So now, next one. All right. So now on number 11, page 23, it's a 7-row proof. Right? I'm not sure if it's going to let me do it or not. Yeesh. Not sure if it's going to get down there. All right, it might. I don't know. We'll try it. 7. All right, and then we may have to make 6 a little smaller, and then 7. Does that fit? Yeah, we'll have to make it fit. All right, so 1, I have AC is congruent to DF. And I have BC is congruent to DE. Oops, sorry. Given. All right, and so at the very end, I have to prove that AB is congruent, okay, to EF. All right, now if I'm getting to this point, so far, every time I've had to do that, I've had to do this. Okay, so I know that step 7 is going to be congruence. Okay, I know step 7 is going to have to be congruence. So now let's start taking these apart, and let's just look at these as okay, so if you've started with congruence, you know you got to change to equality. That's the definition of congruence. Okay, and so now if I start adding some of these together, like segment addition postulates, which again, we're looking at this part right there. Okay, so I can say that AB plus BC is equal to AC, and I know that DE plus EF is equal to DF. All right, so I have these two separate parts. So this is going to be segment addition. All right, so now on step 4. Okay, so now I have, if AB plus BC equals AC, DE plus EF equals DF, okay, and I'm told at the top AC is equal to DF, okay, so I know that the whole line is equal to that. I also know that BC is equal to DE. Okay, so now I need to start plugging some things in. All right, to where if I take AB in step 4, okay, if I take AB, all right, AB plus BC, I know that BC is equal to DE. All right, and I know that if I take this part is equal to that, and I add this, which is equal to DF, I know that the whole thing can equal DF. And why is that? Okay, well again, let's go back to what we see here. Okay, AC is equal to DF. Well, if I take AB plus BC equals AC. Well, I also know that BC and DE are the same. All right, so I know that AB plus DE, I could make it equal to AC, but I need to make it equal to DF because this is what I'm shooting for down here. So I know that that's going to equal, and that's just substitution. I filled that in. Substitution. Okay, so now at number 5. All right, so if we know that this is our next step, okay, this is our next step. So if I got this, AB plus DE, I know that's going to equal DE plus EF. Okay, and again, that's going to be transitive. All right, so if this is equal to this, I know I can rewrite this like this up here. And that should be df, sorry. There we go. Okay, so hopefully you can see that. Yeah, you can see that. All right, so now, what happens if I take the dE's out? Do I get AB is equal to EF? Yes, I do. So if I would subtract both, okay, I'm down here to where I need to be. AB equals EF, and then I can make them congruent. All right, that was number 11. Okay, and the last one. I'll go ahead and erase all of this. And it is I can't remember what this one is. I think it's a 7-step proof as well. So 1, 2, 3, 4, 5, 6, 7. All right. Oh, they're a little off. My fault. Let me go to there. Okay, and I have 3, 4, 5, 6, 7. All right. Okay, so we always know what goes up here, given. Right, and I have AB is congruent to CD. Okay, I have to prove that AC, okay, that AC is congruent to BD. All right, now, whenever we know this, we know that the step above it has always been this. So we know that this is congruence. Okay? And then when we've always been given this, we always know that the next step is this. And that's based on congruence. Ha-ha! Okay? So before we even start, we already have 1, 2, 3, 4 statements, and we have 1, 2, 3 reasons. Okay, so now we just got to go from here to here. All right? Okay, and this is where we look at our lines, okay, to see what do they equal. Well, I know that AB plus CD, okay, I'm sorry, this is number 3. That should be AC. My fault. I was looking up at AB. So AC plus CD is equal to AD. All right. And then also AB plus BD. AB plus BD is equal to AD. Okay. And this is all off that one line. Okay. If I hold it up here again, it's all based on this line. Sorry. It's all based on that line right there. Okay? That line there. So, okay, so I know that that's going to be segment addition. Okay, so now step 4. Okay, to where I take AC plus CD is equal to AD, and BD plus, or AB plus BD equals AD. So now in step 4, I can say CD plus BD equals AD. And this is why. Look back up here. If AB is equal to CD, these two are the same. Okay? And they equal the same amount. So I know that if that is the case, okay, and I come down here and I have these two are the same to equal the same amount, okay, so I know that these two have got to be the same as well. All right, so if I take a look I can now say in step 4, CD plus BD equals AD. Okay, and that is just substitution. Substitution. Okay, so CD falls down here. Okay, BD is right there. All right, because again, these parts are a whole lot interchangeable. So I have it equal to AD. Okay, so then, if I know I'm going to be here, I know that AC plus a certain amount is going to equal that same amount plus BD. Okay? And that common factor is what? Okay, here's BD right here. And so if I take CD plus BD equals AD, then I know that if I take CD twice, those are going to be true. Well, now if I cancel these out, I'm going to be left with this. Okay, so that is number 5 is transitive. Okay, and then number 6, okay, is subtraction. Okay, and those are pages 22 and 23. Again, just trying to give you more insight, and this is all your homework, so all you have to do is follow this video, fill everything in. I expect you to watch it, because if you don't, this is the beginning process, okay, over the next 9 weeks. And so you're going to have to start thinking in these ways, so make sure that you watch today. Hope you have a great evening, and I'll see you tomorrow.